So expanding, this is what we did in unit 6. So 3x squared, that expands to 3 times x times x. Negative 15x, that expands to negative 1 times 3 times 5 times x. So we've been doing a lot of expanding. And then we're going to circle factors that all boxes have in common. So the first box has a 3 and the second box has a 3. So we can circle those. That is a common factor. And then the first box has an x and the second box has an x. So that's another common factor. X is not, because this one has an x and this one does not have another x. And this one has a -1, but this one doesn't have a -1. So we can't circle those. So we're only circling the things that all the boxes have in common. Any questions so far? Next, you're going to write what you circled on the left side of the box. That's your GCF. That's your greatest common factor. So we have a 3 and an x. We just found the greatest common factor. So that's what everything has in common. So they have in common a 3 and an x. Then you're going to write what is left above each box. So we have an x left in the first box, so an x goes on top. And then we have a -1 and a 5. So we multiply it back together. And so we have a -5. And so then our last step is we're going to write the factored expression. So our factored expression now is 3x times x minus 5. So see how now we're doing the reverse, we're working backwards. So we're starting with the area, and then we found the length and the width. Where last unit, we had the length and the width, the 3x and the x minus 5, and then we would multiply to find the inside the area. Okay, let's do one more, because we're also gonna do trinomials. So say we have 5r to the 3rd power plus 12r squared plus 20r. So in this case, we're going to need 1, 2, 3 boxes because we have 3 terms. And I'm just going to make it nice and big since I have the space. And then that way we can put 1 term in each box. So we have 5r cubed in our first box, 12r squared in our second box, and 20r in our third box. And then we'll go ahead and follow our steps. So we drew our box, which was step 1. Now we need to expand each term. So 5r to the 3rd power, that's 5 times r times r times r. 12r squared, that is 2 times 2 is 4, 4 times 3 is 12, and then r times r. And then 20r, 2 times 2 is 4, 4 times 5 is 20, times r. Then we are going to circle factors that all boxes have in common. So do all of the boxes have a 5? This one has a 5. This one does not. This one does. So we can't circle it. It has to be in all of the boxes. This one has an R, this one has an R, and this one has an R. So we can circle that. And it looks like that's it. So we're gonna write that over here. R is our greatest common factor. And then we're gonna write what is left above each box. So we have 5 times R. We just multiply it back. It leaves us with 5R squared. 2 times 2 times 3 times R, which is 12R. And 2 times 2 times 5, which is 20. And so now our factored expression is R times 5R squared. So we write our GCF outside and then whatever was left on the top. So 5R squared plus 12R plus 20. So if we multiply R times 5R squared, R times 12R, and R times 20, we end up with 5R cubed plus 12R squared plus 20R. Okay, so go ahead and open up your workbook to page 77. We're going to practice this.
So much has happened, what we've done.
All right, so number 1. So the first page, they all just have 2 terms. So these are all going to just be using our 2 boxes. So we're going to put 49N in the first box and 42 in the second box. And then we're going to expand. So 49N, that's 7 times 7 times N. 42 is 7 times 6. Then we're going to look to see what the boxes have in common. So it looks like they both have a 7. This one only has 6 left. This one does not. So it looks like 7 is our GCF. And then we are left with 7 times N in this box and just a positive 6 in this box. So the factored form of this is 7, our GCF, times what we had left, 7N plus 6. Because 7 times 7N is 49N and 7 times 6 is 42. And this is page 77 if you're just joining us. Okay, let's go ahead and do number 2. So again, we need 2 boxes. We're going to put the first term in the first box and the second term in the second box. And then we're going to expand. So 9n squared, 9 expands to 3 times 3, n squared, that's n times n, 5 times n. And then what do these have in common? Looks like just an n. There's no 5 in this box, so we can't circle a 5. So our GCF is n. And then we multiply whatever's left. 3 times 3 is 9 times n. Then we just have a 5 left in this box. So the factored form is our GCF, which is n times 9n plus 5. Okay, any questions on factoring the GCF so far? Okay, let's go ahead and flip to page 78. And so now we have the trinomials, we have 3 terms. So since we have 3 terms, we're going to need 3 boxes. So we're going to put 1 in each box. So we have -10r cubed, -20r squared, and 25r. And as you get used to it, you don't always have to write it in here. You can just start by expanding. So -10, remember when we did expanding, we would always expand a negative number with a -1. And then 2 times 5, -1 times 2 times 5 is -10, and r to the third, 1, 2, 3 r's. And then we have -20r, -1 times 2 is 4 times 5 is 20. R squared is r times r. And 25r, that's 5 times 5 is 25 times r. And then we're looking for what do these boxes all have in common? They all have an r. And this one only has 5s. And unfortunately, oh, it looks like all of them have 5s. So 5, 5, and 5. So it looks like our greatest common factor is 5r. That's your GCF. And then we multiply what's left. -1 times 2 times r, so -2r squared. -1 times 2 times 2 times r is -4r. And then we just have a +5 left. So the factored form is 5r times -2r squared minus 4r plus 5. Okay, and I'll do one more. -20b squared minus 4b minus 20. So -20, we're going to expand -1 times, you can kind of look too. So I can kind of already see that there's going to be a 4. So I'm just going to leave it as a 4 times 5 times b, because I know this one already has a 4. And then -1 times 4 times 5. And there's my 4. And it looks like that's it that they have in common. So we're left with -5b squared, -1 times b, which is -b, and -1 times 5, which is -5. And you can always check. So 4 times -5b squared, does that give me -20b squared? Yes. 4 times -b, does that give me -4b? Yes. And 4 times -5, does that give me -20? Yes, it does. So we know we factored correctly. And our answer is 4 times -5b squared minus b minus 5. All right, any questions? I'm going to assign you guys some problems to do. Okay, so let's have Amari, can you do number 3? Bella, can you do number 4? Dakota, can you do number 5? And Esmeralda, do number 6. And then on the back, let's do some on the back together. So Kaleni, can you do number 13? Savannah, number 14. And Tiana, number 15.
I'm already completed mine.
Okay, very good. We'll go over them in just a few minutes. Yeah, so Savannah Gill, you are doing number 14. Okay, so let's go ahead and start going through these. So Amari, can you tell me how you did number 3?
Well, for -2n, I found 2 and 6.
Hold on just a minute. Let's see. Okay, there.
The greatest common factor is -2.
Okay, and how did you get that? So what did you expand in the first box?
I did the equation -2n and 1.
So -1 times 2 times n?
Yeah.
Okay, and then how do you expand -6?
-2 times 3.
Okay, and we don't know which one's the negative, right? So that's why we always want to use -1, because it could be either, it technically could be either one, and if we make the 2 negative, then we wouldn't be able to circle the 2's. So always just make sure to expand with the -1.
Okay.
And so then you're right, yes, our common factor is -1 and 2, which you said was -2, and then what are we left with on top?
I don't know how to do that part.
It's just whatever's left, whatever you didn't circle.
Oh, okay.
So in the first box,
it's n.
It's n, and in the second box,
3.
Yep, a +3. So the factored form of this is -2 times n plus 3.
Okay.
Good, thank you, Amari.
Mm-hmm.
Okay, Bella, number 4.
So for the first box, you expand to -1 times 3 times 3 times r.
Very good.
In the second box, you expand to -1 times 3 times 3 times 3.
Very good. And then what can we circle?
You could circle the -1
Very good.
and 2 3's.
Great. So our common factor is?
-9.
Yep.
And you are left with r squared and +3.
Great job. Thank you, Bella. All right. Number 5, Dakota.
I got help on this yesterday, so I don't have that paper that how I did that. So I wrote on different papers. I only have to answer.
Okay, so then why don't you go ahead and tell me your answer, and then we'll go through it and see how you got it.
N plus 6.
For number 5? You might be on a different one.
Let me see.
That's okay. I'll just go ahead and go through it.
Oh yeah, I was on the wrong page.
Okay. So negative, you want to do it with me, Dakota? How would we expand negative?
The answer is 5. Then the parentheses, negative 3n squared 2 plus 3.
So 5 and then negative 2. Do you mean r?
Oh, sorry, yeah, that means r. Yeah, I meant r.
R plus 3, right?
Yeah.
Yep, you're correct. Okay, so let's see how Dakota got that. So negative 1 times 2 times 5, we expand times r, and then 3 times 5. So then we can take out the 5. That's how she got the 5 here. And then we're left with negative 2r squared. I'm not sure if you said that, Dakota. So that's negative 2r squared. And then we're left with a 3 in this box. So plus 3.
Yeah, I did say squared. I said squared too.
Okay, good. Sorry, I missed that. Okay, so you guys will have to finish 6 through 10 on page 77 on your own. Let's go ahead and flip to page 78. And Kaleni, I know you were having some questions on number 13. So I can help you go through it. So let's see, we have negative 4b squared plus 20b minus 20. Okay. So I'll just go ahead and go through this. So we have negative 4b, negative 1, and I can already see there's going to be a 4 because I see 20 and 20. So I'm going to leave it as a 4 instead of expanding to 2's. And then I'm going to use this one. I'm going to make sure to expand with 4. 4 times 5 times v, negative 1 times 4 times 5. And so they all have a 4. So that's my GCF, my greatest common factor. And then negative 1 times v is negative v squared. 5 times v is positive 5v. And then negative 1 times 5 is negative 5. So once I take out my common factor, I'm just multiplying what I have left and writing that on the top of each box. So the factored form is 4 times negative v squared plus 5v minus 5. Any questions on number 13? Okay, and then Savannah, can you tell me how you did number 14?
I was a little like on this one. So I got a box, I think, filled out with stuff, but what doesn't make sense is unless you map out a number specifically that you want, you won't have it in the same, like in the problem you just did in number 13, you knew and you looked at it ahead of time and knew that you should have done a 4. And so that's where I'm like,
okay, no, you gave a good point. So the only reason why I did that, if you expand completely where nothing else can be expanded, you'll always find the common factor. Once you get the hang of it, you'll kind of see like, why write 4 as 2 times 2 and 2 times 2 and 2 times 2 if I can already see that there's a 4.
I see.
So I kind of already know like 4 goes into 4, it goes into 20, and it goes into 20. And so it just saves us a step. But if to be safe, you can always expand completely, and then I would just circle the 2 2's in each box. So either way, you'll come up with the same answer. So if that confuses you, just always expand completely.
Okay. Well, just let you know, I don't think I have the correct.
Okay, I think you got it. So let's just do it together. So how would you expand 5n?
I think I would do 1 times 5 times n.
Yep. And then what about negative n squared?
Negative 1 times n.
Times n times what else?
And then n times n.
Right?
Maybe.
And then how about negative 5n to the 4th?
I have negative 1 times 5 times n, and then obviously the 4 times the n too.
So 4 n's, yes. 1, 2, 3, 4. Yep. Okay. And then now we need to circle what all the boxes have in common. So what do they all have in common?
Well, the negative 1 isn't in the first box.
Yep.
And there's no 5 in the middle.
That's right.
So
So
what do
all
we circle?
there's one thing we can circle. What is it?
There's the N.
The N. So that's it. That's our greatest common factor. That's the only thing they have in common. Yep.
I think I was only confused by that because no one else had an N. I was like, am I doing something wrong?
And
So I
sometimes
guess
there may not even always be a common factor. On this assignment there is, but we're gonna get to two-step factoring there's not always a guarantee that there will be a common factor. On all of
that
these
makes me
there is, but
that makes me feel better.
So then now, what do we have left if we multiply back in the first box? What am I gonna put up here?
I didn't get to this step yet. So like, do we involve the N's? Like,
so now we've already taken out the N's. So
okay.
we're just gonna multiply back whatever we haven't circled, and that goes on top.
Oh, I see. 1 times 5 minus 1 minus 1 times 5. That's
okay. So individually, so just looking at this box, we have 1 times 5. So just 5 is going to go up here.
Oh, but wouldn't it be everything else without the?
Yes. So we're going to get to those too. But the reason why we do it one box at a time is because now if we multiply the length and the width of this box, n times 5, we get our 5n.
Oh.
And then now for the second box, we have -1 times n, which is -n. And see, when we multiply these back, n times -n, we get what we started with, which was -n squared.
I see. Okay.
And then in our last box, we have -1 times 5, which is -5, and we have 1, 2, 3 n's left. And now if we multiply n times -5n to the third, we end up with -5n to the fourth.
That makes more sense.
So check.
So the whole point of the problem is to, like in 13, the whole point was to find 4, so you could then just place in the stuff.
Yep, we're trying to find the greatest common factor.
Is there like an easier way to do it without the box and like the long process of that?
It would all be mental without the boxes. Like when I was in school, that's what I was taught, is to just look at it and what do they all have in common.
Mm-hmm.
And they told us, oh, to just take out an n, and then what do you multiply to get 5n? And well, that would be 5. So, but this way you at least have like a visual representation to get to that. I think it's a lot friendlier than expecting you to be able to figure it out in your head.
Yeah, but if you look at number 14, you can see that each one of them has an n in it.
Yep, you're right.
Can you do that? If you mentally did it in your head, can you write it down instead of doing the whole problem with a box?
Mm-hmm.
Thank you.
Okay, so someone just joined us. We are on page 78. And then we have one more to go over. So Tiana, you want to tell me how you did 15?
Well, I did a different way instead of the box.
You guys don't like these boxes, huh? Okay, what did you get, Tiana?
3, the parentheses, 3n to the third power, plus 4n squared plus 1.
Yep. Okay, good.
But I could also do the box too.
Okay, so how would you do the box? Go ahead and tell me.
3 times 3, n times n times n.
Yep.
And then 12 would be 4 times 3 times n times n.
Yep.
And 3 would be 1 times 3.
Excellent. Yep, and then what would I circle?
And the 3.
So that's my GCF. And then I'm left with exactly what you gave me down here. So 3 times 1, 2, 3 n's, 3n to the third, 4 times n, which is 4n squared, and then just a 1. Very good. Thank you, Tiana. So the boxes, I've taught this every year, and students always, they never really like the boxes, but they get the right answer a lot more times than not, than if they don't use the boxes. So I know it's a little bit uncomfortable at first, but I think if you practice and continue to use them, they're really helpful once you get the hang of it. And then you'll see the next thing that we're going to go over is factoring with 4 boxes, these trinomials, and the boxes are really helpful for that too. So let's go ahead and switch back to our notes. And we are going to factor trinomials where A is 1.
I finished the trinomial where is 1. No, I finished that one already.
Okay. You're free to go then, Dakota.
Okay.
Okay, so our next step in factoring is factoring trinomials. So something like x squared plus 5x plus 6. And so for these, we're always going to need 4 boxes. So the first thing is we're going to draw a 2x2 box with a box in the middle. So I'm going to do 4 boxes by 6 boxes. And then we're going to draw our box in the middle. And you're going to see why. And then step 2 is we're going to label the boxes. So again, remember we're working backwards. So we have the area of our boxes. Now we're trying to find the length and the width. So remember, x squared term always goes in this box. And then 5x goes in this box. And 6 goes in this box. So remember, just like this, but now we're working backwards. So instead of being given our sides and multiplying, remember we would combine our like terms of these 2 boxes. That's why we have this 5x here, because we know these 2 boxes combine to give us this box. And we know that these 2 sides multiply to give us this box. So the next step is we're going to find the sides of the top left. So we're asking ourselves, what 2 numbers or variables multiply to give us x squared? X times x. Then to figure out these, remember these 2 boxes have to add to 5x. And then this number times this number has to multiply to 6. So we are going to find the other 2 sides by asking ourselves what multiplies to 6 and adds to 5. So they have to add to 5, but multiply to 6. So maybe you guys have done this before, the x. And so you're trying to find what multiplies to 6. I forget if the multiply goes on the top or the bottom. So what multiplies to 6 and what adds to 5. So 3 and 2, right? Because if we do 3 plus 2, that gives us 5. If we do 3 times 2, that gives us 6. So then we know 1 is plus 2, and we know that 1 is plus 3. It doesn't matter where they go. Because if we multiply x times 2, we get our 2x. And if we multiply 3 times x, we get our 3x. 3x and 2x add to 5x, and 3 times 2 gives us our 6. So by multiplying x plus 3 times x plus 2, we end up with x squared plus 5x plus 6. So our last step is we just write the factored expression, which is x plus 3 times x plus 2. Okay, any questions so far on the notes? Okay, so let's go ahead and turn to our assignment on page 79. Okay, so these are all, they're all trinomials. We're gonna need 4 boxes for all of them with our little box in the middle. And then we're gonna fill out our diagonal. So we're gonna put p squared here, 11p here, and 10p here. Any questions how I set up my box? Okay, so now we want to find the sides of our first box. So what multiplies to give us p squared? We only have one option, p times p. P times p is p squared. And then we need to figure out what multiplies to 10 and adds to 11. So you can use your little x, what multiplies to 10 and what adds to 11. So it looks like that would be 10 and 1, because 10 times 1 is 10, 10 plus 1 is 11. So we would put p plus 10 and then p plus 1. And we'll finish filling it out. P times 10 is 10p. 1 times p is 1p. 1p and 10p, yep, that adds to 11p. And 1 times 10, that gives us our 10. So we know we did it correctly. And so the factored expression is p plus 1 times p plus 10. Those are what multiply to give us p squared plus 11p plus 10. And sorry, yes, we are on page 79. Okay. Let's do another one. One more together. So we have n squared, 7n, and 10. So what multiplies to give us n squared? That's n times n. And then what multiplies to give us 10 and adds to give us 7? looks like 5 and 2. 5 times 2 is 10, 5 plus 2 is 7. So we can put plus 5 and a plus 2, and then check our work. 5n and 2n, yep, that adds to 7n, and 2 times 5, that gives us our 10. So this factors to n plus 2 times n plus 5. Okay, so we have 12 minutes left. I had a Kahoot for us to play for extra credit. And I know a lot of you have to leave right at 11. So is it okay if you guys finish factoring page 79 on your own and then we can go ahead and play the Kahoot? Or do you guys just want to work on this page together for the last 11 minutes? You can send it to me in the chat what you guys want to do, or tell me what do you guys want to do. It's up to you guys.
Can we finish this?
Okay, sure. And that's the one message that I got. Okay, so we'll keep working on page 79 then. Okay, so for number 3, I'll go ahead and do one more with you guys and then we can kind of break it up and you guys can practice on your own so we can figure out where we're struggling. Okay, so we have x squared, 11x, and 18. So we label down the middle. Okay, and then we're just working backwards, trying to figure out what's going to multiply to give us x squared. That's going to be x times x. And then remember, we're trying to figure out these two boxes have to add to 11x, and then these two multiply to 18. So what multiplies to 18 but adds to 11? So we could try 6 and 3. Most of us think 6 and 3 for 18, but if we add 6 and 3, that only gives us 9. So we know it's not going to be 6 and 3. What else multiplies to 18? 9 and 2. 9 times 2 is 18, and 9 plus 2 is 11. So those are the numbers we want. So we're going to write plus 9 and plus 2. Because x times 9 gives us 9x. 2 times x gives us 2x. So then those two boxes give us our 11x. 2 times 9 gives us our 18, which is exactly what we wanted. So the factored form here is x plus 2 times x plus 9. Okay, and let's do one more because all of these, the first 3 were all positives. And so let's look when it gets a little bit trickier when we have a negative. We just have to be a little bit more careful. Still the same steps though. So negative 15n and 50. So what multiplies to give us n squared? That's n and n. Now we need to figure out what multiplies to give us 50 and what adds to give us negative 15. So since we're multiplying to a positive and adding to a negative, I know they're both going to be negatives because two negatives multiply to a positive and add to a negative. So this is where you'll just have to be really careful. And then let's see, 50 and 1 isn't going to work because that's not going to get us anywhere near adding to 15. So we're probably looking more at 10 and 5. So negative 10 times negative 5, that gives us positive 50. Negative 10 plus negative 5 adds to give us our negative 15. So those are the two we want. So this is going to be n minus 10 and n minus 5. Because n times negative 10 is negative 10n, negative 5 times n is negative 5n. Those give us our negative 15n, and negative 5 times negative 10 give us our positive 50. So our factored form is n minus 5 times n minus 10. Okay, any questions on number 4? Okay, so let's go ahead and finish this page with the last few minutes we have. So Amari, can you do number 5? Bella, number 6. Kaleni, number 7. Melanie, number 8. Savannah, number 9. And Tiana, number 10. And then on the back, Esmeralda, number 11. And Nathan, number 12. Okay, let's go ahead and start going over these. If you need help, I can help you if you don't have time to finish. And it looks like it froze on my camera. Okay, there we go. So let's see, Amari, what did you get for number 5? So we know it's n. What did you find multiplied to 1 and added, sorry, multiplied to negative 42 and added to 1?
I kind of got stuck there because I didn't know that n was 1. But yeah.
So that's 1n, right? So anytime it's just a number and there's not a number in front, it's always a 1.
Okay.
So then what would multiply to 42 to negative 42 and add to 1? Any ideas?
It would be negative 41, right?
Well, I don't think those are going to add to 1, right? So it's going to be two numbers that are only one number different.
Mm.
So what else multiplies to 42? What about 7 and 6, right?
Oh, yeah, 7 and 6.
But it has to add to a positive 1. So one of them has to be negative, so it multiplies to negative. So since it adds to a positive, the bigger number is going to be positive and the smaller number is going to be negative.
Okay.
So then this would be n plus 7 times n minus 6. Because 7n minus 6n gives us positive 1n, and negative 7 times, or sorry, negative 6 times positive 7 gives us negative 42. So this factors to n minus 6 times n plus 7. Okay, Bella, number 6. What did you get that multiplied to 20 and added to 12?
I got 10 and 2.
Excellent. So then n plus 10 and n plus 2. So then what's the completed factored form?
N plus 2 times n plus 10.
Excellent. Thank you, Bella. And then number 7, we had some movement, some people leaving and some people joining. Who had number 7? Is the person who had number 7 here?
I
It was,
had it.
okay, Kaleni.
I didn't really finish all.
Okay. I'll help you out. So we just need to know, we need it to add to 9 and multiply to 14. So can you think of what would multiply to 14? And 7 and 2. Good. And then to 7 and 2 add to 9?
Yeah.
Yeah. So then those are our numbers, our 7 and 2. So we're going to put our plus 7 and our plus 2. You've got it. So a times 7 gives us our 7a. 2 times a gives us our 2a, which then those two boxes give us our 9a, and 2 times 7 multiply to give us our 14. So our answer is a plus 2 this side times this side, which is a plus 7. Okay, and then Melanie, did you have number 8?
Yeah, I had it.
Okay. So what did you get? What multiplied to negative 4, or sorry, what multiplied to negative 32 and added to negative 4?
Well, I got negative 4 and 8. I don't know if that's right.
Okay. Oh, sorry. Negative 4 and positive 8. So you're on the right track because negative 4 times 8, that multiplies to give you negative 32. But if we add them, our positive's bigger. So this would add to positive 4. So we just want to switch the signs. So do a positive 4 and a negative 8, because then that still multiplies to negative 32, and then that adds to negative 4. So you're really close. So then a times 4 gives us our 4a, and negative 8 times a. And then now those add to our negative 4a, and then those multiply to our negative 32. So this is a minus 8, this side, times this side, which is a plus 4. Okay, and then Savannah, did you have number 9?
Yeah.
Okay, so what did you get? That multiplied to negative 63 and added to negative 2.
I think that if you can even see. I think that I got 7 and then the positive 7 and negative 9.
Very good. Positive 7 times negative 9 is negative 63. And if we add them, 7 minus 9, that is negative 2. Excellent. Oops. So a minus 9 and a plus 7. Perfect. Those add to negative 2a, and 9 times negative 7 multiplies to our negative 63. So our answer is a plus 7 times a minus 9. Okay, and then I think Tiana had to leave. So I'll go ahead and do number 10. So what multiplies to 36 and adds to 13? I think that's going to be 9 and 4, because 9 times 4 is 36. 9 plus 4 is 13. So n plus 9 and n plus 4. 4 times n is 4n. N times 9 is 9n. Now our two boxes combine to give us our 13n. And 4 times n multiplies to give us our 36. So the factored expression is n plus 4 times n plus 9. Okay, and then Esmeralda left, so I'll go ahead and do hers. So we have n squared plus n minus 2. So it multiplies to negative 2 and adds to 1. There is a 1 in front of that n. That would be 1 and negative 2. Oh, nope, that would be positive 2 and negative 1, because we want it to add to a positive. So n minus 1 times n plus 2. Okay, and then Nathan, I saw you had sent your answer over in the chat. So let me see. You got x minus 7 and x minus 9. Very good, Nathan. So we get negative 7x and negative 9x, which adds to our negative 16, and then negative 9 and negative 7, which multiplies to give us our 63. So this is x minus 9 times x minus 7. Okay, so we are a few minutes over. Any questions on our factoring? Okay, so you'll just have to, for the week, go ahead and finish the assignments that we started. So you have a little bit on page 77 that we didn't get to finish, and then go ahead and finish the back, and then just the back of this assignment as well, and then just the checkpoint, and then you're done for the week. And if you don't have any questions, you are free to go. A few of you are going to go ahead and stay on with me, and we're going to work on your missing assignments. So if you got the email from me yesterday, go ahead and stay on, and then we will work on those assignments. The rest of you have a great week. Thank you guys for coming.